not a difficult, it is easy. Program execution started, program execution ended. Actually, destructor concept not necessary to explain. If I say that destructors not necessary, we don't use in real time, what you will feel immediately? You will think negatively. Natural. Even I also think if my sir says not necessary, not necessary to use it, I don't explain, you will say immediately you will see different way to look at me. You will look at me differently. Correct? Natural. But after listening my class, you will say, I will ask the same question. Is destructors required in real time or not? You will say, sir, not at all required, you will say. That's why you look at me differently. I will explain so thoroughly. Let it be 1 hour, 30 minutes waste, no problem. But it is most important in interviews. That's why listen carefully. Now I'm going to start. Program execution started. E is equal to employee. What is this line is called? Good. Object creation. Do you have any object? Object creation makes the PVM to call constructor. Object creation makes the PVM to call constructor. Do you have constructor in employee class? What is the value of E? Empty. What is the value of E? How do you print that? Print of E dot underscore dict underscore, not underscore list underscore. Correct? Yes. So we will be going for one constructor I will define. See students, you tell me 10 comma row sum I am writing. 10 comma row sum I am writing. What did you understand this? Come on. Parameter is a constructor. Object creation makes the PVM to call what? Parameter is a constructor of each class? Employee class. Of each class? Right. Now I will define. It is mandatory to define the parameterized constructor in the class. DEF. I forget. What is the syntax of constructor? Underscore init underscore of self comma envo comma ename. Okay. Self dot envo is equal to envo. Self dot ename is equal to ename. Very good. Now I will print it. See students, I will print it. I say backslash t. I say start dot format of self dot envo comma self dot ename. Okay. Now you execute it. Program execution started. Program execution ended. Okay. You execute it. No issue. Slowly I will go to the 6 p.m. I'll say here oops. I'll go for what? Constructor. Destructors. I'll go for it. Inside of it, I will save my code. Non-destructor example 1.py. Go to the command prompt. Say there D colon. See this now. Python here. 6 p.m. Oops here. Say there. I will go for what here? Destructor I will take it. See this. I say py. Output is coming. Object created or not? Yes. What is an answer? Programmer defined constructor is printing. I will write it. I am saying that print of what? I am from just one line I am writing now. I am writing here. I am from constructor. Okay. See that I am from constructor. Getting the data or not? Yes. Getting the data. I'll write some backslash n and don't get any tension in the middle of it. Program execution started. Program execution ended. In middle of it, constructor calling and values are printed. Are you following, ma? Yes. Ultimately, my interest is this is a constructor part. Okay. One more object I will create. This is what I am calling it is E1. One more object I will create. What is my object? E2. I say here 20, something, some name I will write it, Travis. Some name. Second object also created. Second time also constructor is calling. Easy? Yes. So no hurry. Carefully watch it. How many objects created? 2 objects created. Okay. How do you find the memory space of that? Do you find the memory space of this E1? No. So far I did not tell you so far. I did not tell you so far in the class. Today only I am saying. ID of E1 will give you memory address. That is not the size. To get the memory of that, there is one small function is there. What is that function is? sys dot get size of what? E1. What is sys? Don't take much time. What is sys? What is size of? Function name. Function name. Sys dot exit of. What is sys? Module name. What is exit of? Function name. What is sys? What is get size of? Right, I am writing here print of what is that now? Size of E1 object is equal to size of E2. Size of E2. I will write E2. Now I am writing E2. Just execute it. Ma size of import sys. Import what? Sys. See that. What is the size, ma? 48. And then what? 48. How much memory space? How much memory space? 48 plus 48. 96. Correct? So total memory space of my program is how much? 96. Are you following? Right. Dinesh is asking, is it possible to have 2 unit constructors in one class? He must write an imposition. He must write compulsory an imposition. Mr. Dinesh, this is what is called a little inconvenient for you. You are out of order, I hope so. So go to the part, because I have to show you. Because if these questions are asking, I'll get lot of disappointment. Yesterday's class, my dear student Dinesh, types of constructors. You see, last part, Mr. Dinesh, you take care. In this class, most important point, yesterday's class I told, first I will send him the answer. So, send him the answer. I send him the answer. In a class of Python, we can't define both the default and parameter as a constructor, because PVM can remember only latest constructor. Because of not practicing, this type of doubts will come. Due to what? Interpretation process. To fulfill the need of both the default and parameter as a constructor, we define a single constructor with what? Yesterday I explained now. Again the doubt comes, what can I do? Okay, Dinesh, you are absent. Okay. So that's what, my dear student. Already this point is explained. Yesterday only that was completed. Yes. Come to my topic now. Come to my topic. Now I'm going to say class employee. What is this now? Constructor. How many objects are created? Right. How do you find the memory space? Sys dot get size of. In NumPy also I need this. Slowly I'm injecting. Okay. It is also one question in interview point of view. How do you find the size of an object? How do you find the size of an object? Get size function of which module? Sys module. Okay. Total memory space of my object. Sys dot get size of what? E1 plus sys dot get size of what? E2. So that will give you total memory space or not? Yes. Coming to next part of it. This is completed. Observe the style of this answer. Once program execution started, once program execution ended, once your program comes to an end, once the program comes to an end, what is happening this PVM? Once your program execution is ended, internally one program is running behind of your program. What is that program is called? Garbage collector is running. What is that garbage collector is doing? What are all the memory space is allocated for your objects which are automatically removed? This is called what? Program execution started. Your computer assigned the memory space for your objects of your Python program. Once your program execution completed, PVM will inform to garbage collector and please take these resources back and add to the computer main memory. Did you understand? So behind of your program execution, there is a garbage collector is running. That garbage collector is only the function which is running internally. Behind the garbage collector, there is a concept called destructor is there. What is the concept called? Destructor is one of the function which is defined inside of where? Garbage collector. Inside of garbage collector, there was a destructor mechanism is written. So behind of your normal program who is running, in the garbage collector, what is calling? So who is going to destroy the memory space of your objects at the end of the program? Destructor actually. Destructor is a part of what? What is the relation between garbage collector and destructor? At the end of every program in Python, the garbage collector will do the cleanup process by calling what? Destructor. So who is bottom level removing the memory space? Destructor. Destructor is a part of what? So what is running behind of your program? Garbage collector, which is internally calling what? Destructor. I want to show you the proof. Concept is okay. Now I want to show you the proof. Shall I go for now? Yes. In this case, even if I don't write destructor, nothing will happen. Why? Already garbage collector is running. You may ask a question, sir, how do you know that garbage collector is running? Can you show some proof? That is what I am saying today. Complete explanation I will give you. At the end of it, you will say destructor is not necessary, you will say. But I will explain that. Let me go to that. Same program I will take it. Let me take it. I am going to this place. Today, I will take this class. Take care, students. Next program I am going to take. See, students, I am writing. Here, destructor example 1.py. First time you are writing sys remove class employee. This is called constructor or not? Constructor. Who is calling constructor? PVM. Used for what? Object initialization. Well, good. Next time writing, first time I am writing destructor. What is the name of the destructor? DEF underscore underscore del underscore underscore of self underscore underscore of self. What is it called? Destructor. Actually, this destructor you need not to write. This destructor was already defined inside of where? Garbage collector. Okay. Suppose if you write it, what is happening, sir? I am defining. First time, this is taking only self. We cannot pass any formal parameters. Such type of syntax is not there. Here I am calling GC calls underscore underscore del underscore underscore del after object destruction. After object destruction. It is only for your proof purpose I am writing. No need to write any destructor by yourself in real time because garbage collector is already running and it will call its own destructor to eliminate the memory space. Even if you write your own destructor, nothing is going to be given for you and it is your waste of time. So I am going to say destructor, this is called. I just written one small sentence. So DEST, 1 minute, destruction. So destruction, object destruction calls GC calls DEL after what? Or during, this is the correct word, object destruction. Just to follow. Now I am writing, come to the main program. Like previous program you come. Take care. Here you write it. See that What is happening? Start. Program execution started. What is created? Object created. Remove that. Remove this. Now, come on, line number 13 started or not? What is calling here? What is calling here quickly? Constructor. What is calling again? What is happening here? What is happening here? Object creation done or not? Next, what is happening? Program execution ended. Once program execution ended, what is happening? Automatically, when it comes to this line number 17, indicating that no more statements are there, your GC automatically calling what? Destructor. Destructor means it will see. GC is containing what? Destructor whose name is called like that. It will call. After calling, just only proof is showing that destructor is internally called by whom? Garbage collector. And don't think that this destructor present in GC. GC contains its own destructor. Already it contains a beautiful code of what? Taking whatever the objects you are passing, whose memory space is automatically removed by calling its destructor. Today I am writing this destructor to show you that after the program execution is over, destructor is calling internally by the garbage collector. Execute. See that. I am going to write it. Take care. Now I am going to say careful. All of a sudden answer is coming. PY DEST example 1.py. Try to involve in my explanation. The moment when program execution is over, destructor is calling. How many times? 2 times it will call. Why? First time object destroyed. Second time object destroyed. How many objects? Self. Self means first time this E1 will be removed. Second time this E2 will be removed. How many times destructor is calling? So garbage collector is internally calling destructor how many times? At the end of the program or beginning of the program or middle of the program? Which is known as automatic garbage collection we can call. Spell out. Yes. Execute it. See the students. See that program execution ended. GC calls what? Underscore underscore del during object destruction. GC calls underscore underscore destruction object destruction. At where it is calling? End or middle? End. Now you run your previous program. Non-destructor you execute it. Is there any difference between this and this? No difference. Just you are seeing with a practical proof that at the end of the program, what is calling? GC calling what? Destructor. Here I am not seeing anything. It doesn't mean that it is not calling. It is calling here also. Okay, so are you getting? So I am going to give the conclusion that because of writing this, I am making you to understand garbage collector is internally containing its own destructor to eliminate the current program objects, to take your memory space back to the main memory. Understand this? Now, next, this is known as what? I will write it here. Time dot sleep of some 10 seconds. Time dot sleep of some 10 seconds. Import something like time I am saying. Just execute it. That is the first program you execute it. And see that after 10 seconds, what is happening? Destructor will call. Why I am showing this 10 seconds? You should understand at the end of the program, our GC will automatically call its own destructor to eliminate the current object's memory space. In real time, no Python developer will write destructor. Why? Garbage collector already contains what? Destructor. Why I wrote a destructor in this class? Because to show you that it is calling. Are you following? Yes. So I am just calling this. This is known as which constructor? What type of this? At the end of the program, GC calls destructor, DC call destructor for removing the memory space of removing the memory space of what? Current program objects. Current program objects. And this facility is called, and this type of GC collection is called automatic garbage collection. What collection? Automatic garbage collection. Automatic garbage collection. Are you following me? Next, I want to show you some memory space mechanism. What is my memory space mechanism? Try to call it. Destructor example 2. Tell me. Here I am going to take TOT memory space. TOT memory space is equal to sys dot. I am doing some calculation. If you are capable of understand this. Actually, this logic we don't write in real time. If at all somebody is asking what is your technical awareness about garbage collector, you need to write this. Get size of what? E1 plus E2 plus E2. Are you following? Yes. Now what is happening here? What is the total memory space? Total memory space at line number 18 is equal to I will write it dot format of what? TOT memory space. Actually, this much complex explanation not necessary. Just I am showing to you. What is happening because of that? Come to that. Because of this, what is happening? I will print. GC calls this memory space. Print of what is that now? Available memory space is equal to, I will write it dot format of total memory space. Before that, what I should do? TOT memory space is equal to what should I write it? Is equal to TOT memory space minus sys dot get size of self. Size of what? Self. What is self? Right. And since I am modifying it, what should I write it? Global. Already almost forget. Always global memory space. Destructor example 2.py. Destructor example 2.py. TOT memory space not defined. Spelling mistake. TOT memory space. I will take same variable name. Why to take care about it? I'll just take the same memory space. TOT memory space. And a TOT memory space. See that name, line number, 1 minute. TOT memory space is not defined. Which line it is? 13th line. TOT memory space. 13th line. TOT memory space. Import. Okay. Now, see that. What the memory space is now? 96. Just observe it. What is happening after that? What is the memory space? First one, total one. When first object, first time calling, what is the memory space available? That means which one is removed? First one, 96 minus 48. First object. First time calling now. Removed. What is the memory space available? What is calling next time? Second object removal. What is the memory space? That's all. Easy or difficult? Easy. Now, one more time. One more time. No hurry at all. 3. What is the memory space here? Plus of what? I can say, what is that? E3. E3. Online students. Take care, my dear students. Save. Execute. Execute. See that. Total memory space 144. 48, 48, 48. 3 48s. First object. After 10 seconds. 96. 48. 0. What did you understand with this? This is a perfect way of executing garbage collector. Executing garbage collector. Internally calling what? Destructor. Did you convince with my subject? So, blue t-shirt. ఏం చెప్పట్లే ఊరిగా చూస్తున్నావు నాకు భయం అవుతుంది నువ్వు చూస్తూ ఉంటే. ఆర్ యూ ఫాలోయింగ్? వాట్ ఇస్ ద టోటల్ మెమరీ స్పేస్? 48. 48. 144. 144. First object removed. How much is removed? 48 removed. What is the memory space? 96 minus what? What is that? Next what? In this case, how many objects are active? 3. In this case, what is removed? First object. 144 minus 48. 96. What is next time calling? Second object removed. Minus 48 from this. What is the memory space? Third object also removed. 48 minus 48. This is the called what? In remove, beginning days you remove. What is the garbage collector definition I said? A garbage collector is one of the system background program which is running behind of our Python program to eliminate unused memory space for improving the performance of Python based applications. Beginning days I said. Why I said? Because this is there in my memory. This is called practical knowledge. Are you following this? So what I told you in the beginning days, that definition is important. Still the definition I will carry. Features of Python. First feature is called simple. Second property of Python is called what? Factor number 2. Python programming provides a garbage collector whose role is running behind of regular Python program for collecting unused memory space, improves the performance of garbage collector, takes care about automatic memory management. 144, 98 and then 48 and then 0. Is it not called automatic memory management? Easy or difficult? Easy. So whatever the definitions we say, they are all called practical. That's why don't miss a single word of our definitions. If they ask how you show me how it is running, show it. You see any book, nothing is there. No book will contain that. Because you have to prepare by yourself this type of case studies. Did you understand? Good. Let us move to the further. Let us move to the further. My dear student, Johar, what is happening? Coming to the point back. Are you chatting with your friend or what? Right. Coming to the point of it. Now I am going to say, what is this collection is known as? Automatic garbage collection or not? Yes. Now I want to tell you, this is known as what? What collection it is? Automatic garbage collection. This mechanism is known as what? Read once again. At the end of the program, GC calls its destructor for removing memory of what? Current program objects. This type of GC, this type of what? GC collection is called what? Automatic garbage collection. Now, in your mobile app also, for every 12 hours, internally one performance booster is running. That is known as what? Automatic garbage collection. Understand? In Python programming, you can have one more type of garbage collection also. What is that garbage collection is called? Forceful garbage collection is also there. How many types of garbage collections? Two. One is automatic garbage collection. One more is forceful garbage collection. This is known as which collection? Automatic garbage collection. Is it necessary to write my destructor? No. No. Did you understand first of all this global everything? My main program variables are called global variables. Global variables I am modifying inside of the function. So it is called global keyword. Need to write or not? Yes. What is this garbage collection is known as automatic garbage collection. Now I want to go for forceful garbage collection. Shall I go for it? A human being lives for 100 years. 101 year is coming. God has written a garbage collector. Collect away. Correct or not? Within 100 years, something is happening. That is called what? Forceful garbage collection. Don't tell this example. Come to the point of it. Come to the point of it. Now I am going to. Now I will see your smiling faces because a good example is coming. I will tell in interviews. Don't tell, my dear students. Now I am going to say destructor example 3. I am going to say take care. What is my total memory space? 3. What is my total memory space? 1. Okay. Now after that, program execution is over. Line number 18. Line number 18. Total memory space. Program execution ended. All my previous examples, destructors are calling after the program execution ended or not. That is known as which collection? Automatic garbage collection. Now I am writing before the program execution ended. I want to remove my objects. That is called which collection? Forceful garbage collection. In order to call the garbage collector forcefully, in order to call the GC forcefully, where GC can call its destructor forcefully, you have to make your object is equal to none. You have to make your object is equal to none. Are you following? Come on to the point of it. E1, E2, E3. Are these 3 memory spaces or not? As come on to the point of it. I will do what? I will say time dot sleep of time dot. Okay, first I will write it. E1 is equal to what? None. What is the meaning of none? Whatever the memory space is created, which I am doing nullifying, assigning null, means what? Whatever the memory space you have created, this E1 which contains the data, which is containing some address, 1, 2, 3, my E1 is pointing to this memory space or not? You are writing E1 is equal to what? That means E1 is not pointing here at all. E1 is containing the value called what? Automatically, this memory space is pointed by any object? No. Which is eligible to be collected by what? Yes. That is known as which collection? Forceful garbage collection. Now, see, time dot sleep of what? 10 seconds. That means I am writing here print of no longer interested. Just you go on seeing, you will get lot of interest on this coding. No longer interested to maintain the memory space of what? No longer interested to maintain the memory space of what? Of which object? E1 object. E1 object. T1 is equal to, this I will write first, student. This I will write first. Sorry. 1 minute ma. I will bring this. Here I will write it. Here I will write it. You will write this statement on the top of it. E1 is equal to none. Because of this, what is happening? Forcefully, GC calls its destructor. Before program execution only, I am destroying forcefully. Are you following me? Now tell me what is happening because of that. What is happening? You see, I will write it. Now, after that, take care. Which object I am removing? Before program execution ended. Again, I will write it. Program execution ended. After that, what is happening? Time dot sleep of what? 10. How many objects will be destroyed after the program execution ended? 2. What are those two? E2 and E3 will be destroyed after the program execution is ended. So E2, E3 are called which collection? Automatic garbage collection. E1 is called what? Right. Take care. Let us run this code. Let us run this code. Why this example is, if somebody asks you tomorrow, how many types of garbage collections are there? That time you can define. Two types of garbage collections. PY, see the students. What is this memory space? 144. No longer interested to maintain the memory space of E1 object. Take care. What is that next? Time dot sleep of this. GC calls this thing before the program execution called or not? What is the memory space? After this you see, program execution ended. Rest of the objects are called. After the program execution ended, two things are calling. So these two things are called automatic garbage collection. This one is called what? Forceful garbage collection. Did you understand? Well, if you want to call both of them before execution only, no problem, student. You can call once again the same point here itself. I will write no longer interested to maintain E2. I will say E2 is equal to what? None. I will write one more time, no longer interested to maintain E3. What is this now? E3 is equal to none. That's all. That's all. Before each one, I will just take it what? 5 seconds I will take. I don't want to wait for that long time. 5 seconds I will take it. 5 seconds. Last one I will keep 8 seconds. Execute it. Take care, students. Memory space is called 144. And see the next lines. Next lines. One object is removed. 96. Started. Now 96. 48. E3 also not in interested. Also collected. 0. After that, what is happening? UC 0. Program execution ended or not? That means program execution ended. Before that only I am removing my memory space, which is known as which collection? Forceful. Program execution started. Program execution ended. In middle of it only I am removing my memory space. What it is called? Forceful garbage collection. Did you understand? Yes. How many mechanisms of calling garbage collections? 2. One is automatic. One more is, what is the syntax of forceful garbage collection? Making the object is equal to none. Did you understand the meaning? Type is used for making the object as null. Once you make object is null, whose memory space is automatically collected by garbage collector through its destructor. Did you understand? Yes. This is important. Why do you use none data type? You have to tell this example. Beginning day, you did not understand what is none. Did you understand today what is none? Making object none means killing that object. Killing that object. Right or not? Right. 100 years, 100 plus 1 years. Kill is what? Automatic garbage collection. In middle of this 100 years, killing means forceful killing. Did you understand? Right. This is called which type of collection? Forceful garbage collection we can call. Well, can I tell you one more mechanism? Good. Look at that. So many examples I'll tell you. Once we enter into one topic, we must be the master. See, I'll go to next. Destructor example 4.py. Second way of calling the destructor automatically. Okay. Now, E1 is equal to none. Now I am asking one question. Which I already taught to you. How do you delete an object? DEL. long back. DEL can be used for how many purposes? 3 purposes. Deleting an element of any iterable object based on indexing. Deleting an element of any element based on what? Slicing. Deleting the complete object. Is it explained? Today, I will write what? DEL. What? E1. DEL E1. DEL E2. DEL E2. DEL E3. DEL E3. Are you following? When you delete the object, forcefully GC calls it, sir. When you are no longer interested that, delete that object. Once you delete it, whose memory space collected by whom? Garbage collector internally calling what? So who is going to remove the actual memory space? Destructor. Destructor is internally called by whom? Is it necessary to write your own destructor? No need, because already GC contains its own destructor. Did you understand? Now execute this code. Execute this code. I will write one more small line here. Of 5 seconds, I will write it. This is the second way of calling del. How many syntaxes are there to execute? How many syntaxes are there to execute automatic garbage collection? Only one. That is last one. It is completed. Forceful garbage collection. How many syntaxes? Come on. 2. Come on to the point of it. Ajit, look at that. Look at that. 144. Before deletion, Mr. Ajit, take care the counting ma. After deleting, how many? 96. After 96 minus second object removal, what is that? 48. After that, what is that? Finally, what is this? Execution ended. Ajit, none also have the same size now. Same size now, sir. Please look at ma. Look at that. None is also one value. No doubt in that. But I am removing that object now, pointing to some other value. Some size is there because none is also one value. Are you following me? Yes. Did you understand this mechanism? How many syntaxes are there for forceful garbage collection? 2. One is making the object is equal to none. One more is del of object name. Are you confident? Yes. Shall I go to next level? This is called one level of this. What is the destructor? Destructor is also one type of function which is related to what? Object level only. Why? Objects only removing, na? How many objects I created here? How many objects are removed here? 3. If I created 20 objects, how many times destructor is internally calling? 20 times. Right or not? And don't ask me, sir, I want to remove all at once. Not possible. 180 crores of Indians. Removing everything is possible, huh? Not possible. Right or not? Yes. So, whichever object you want, you can delete that object only. That is called actual recommendation. Now, next level. Ready to understand the next level? Well, go to the next point here. Next point here. The next. I will remove such a big coding here. Let me take it. Only this part I will take it. Only this part I will take it. Other thing not necessary. You are already understand the memory space, students. Already you understood the memory space. Or you want to take again? Why should I give doubt for you? Chance of doubt, I will take the same thing. Go to the same. Go to the same. Paste it. Today, I am taking destructor example 5.py. Take care, students. What is E1, E2, E3 are called? Objects. Today, what is E1? Forget about E2, E3. What is E1 is called? Object creation. Object creation makes the PVM to call what? Constructor. Okay. Well, next, take care. I'm going to keep the comment there, students. Some multi-line comment I kept it. Some multi-line comment I kept it. Come on now. I'm asking one important question. E2 is equal to E1. What is this? Very good. Deep copy. Deep copy. long ago, shallow copy, deep copy, slice based copy. Remember? Good. See that E1 is equal to E2. E3 is equal to E2. What copy? Deep copy. Do you know what is the deep copy properties? What is the deep copy properties? Same. Gurtuledu. Same. If you look at like that, I will fear a lot. If you say answers, I will feel very happy. Same content, initial content is same address of both the objects, modifications will be reflected. Yes or no? Now tell me, 3 memory spaces created or 1 memory space created? Huh? Are you sure? 1 or 3? Very good. Very good. Up to here, very good. Oh, up to here only, not total class good. Up to here only. My data is what? 10 rows sum. What is pointed? E1, E2, E3. My address is same. You know that address part, right? 1, 2, 3. Now tell me, E1, E2, 3 objects are there. Now, fine. Now I am going to call it. I am asking a question. You just keep it. This one, you see, program execution ending only I am removing. In middle of it, I am not removing. That code I am not removing. Even in my program, how many objects are created actually? Come on. 3 got 1 only. 3 1 only. How, but why? Because only one address is there. Tell me, when the program execution is ended, how many objects are removed? How many objects are removed? 1 or 3 now? Raise the hands. 1. Okay, 3. మాకేం రాదు సార్ అసలు ఏం ఉత్తగా ఉన్నాం ఇక్కడ హైదరాబాద్లో. Who is that? We don't know anything, sir, like that. How many? Not saying anything. It is going to remove only one object. Why? Because only one ID is there. Only one memory space is there. So only one memory space will remove all of them. Only one. If I remove that one, all objects will be just removed. Just to see that deep copy says that even though there exist 3 names pointing to the same memory space, only one object will be removed. Now see Destructor example 5.py. So many things I'll discuss, students. Carefully follow. Py. See this carefully. What is this? Total memory space. Okay. Keep it comment. Keep it comment. Keep it comment. No issue at all. You see, students. What is calling? What is calling, students? GC calls only one time only. But how many objects? Right. మీకు డౌట్ వచ్చింది మళ్ళీ ఇప్పుడు సార్ డేటా చూపించలేదని. 1 minute. తొందర ఎక్కువ మనకు. సో వాట్ ఇస్ దట్? E1 dot underscore what? Dict underscore comma ID of what? E1. Now I will write it what? E2 and what is this? E2. Next I am writing what? E3. What is this now? E3. Now you execute. See that. First one, same ID. Second one, same ID. Third one, same ID. How many memory spaces will be removed? One memory space only removed. Understand? Yes. Shall I move forward? Yes. Now I'll move to further. Same ID will be there. Same data will be there. It is called one memory space only. Okay. Good. Next level, I'll remove this. Next level, I will remove this. Okay. So I'll say here, something like this I am taking. Right. Coming to the point of it, I will take a total memory space. E1 object. This you remove it, students. This you remove it. If you want, I will take in the next level. Okay. Now you execute it. Now you execute it. See that. What is the memory space? Because same thing is measuring 3 times. But what is removed? Only 1. You don't think that 348, 48, 48, 48. No. 3 times you are measuring the same. That is nothing but what? 1 only calling. Are you following me? I will show you the deep practical explanation for it. Let me move to further. Same example I'll carry. See that. I will take this. Online students, are you comfortable? See, 6.py. What is this now? Total memory space is done. You remove this. Remove this. Now, here, after this memory space is done, which one I am going to remove? E1. This is my picture. One important situation is coming. E1, E2, and then what? E3. E1, E2, E3. Same address. 1, 2, 3. How many people are pointing to the same address? How do you remove this E1? Come on, I already told you, students. DEL of what? E1. That means I am saying to you that I am no longer interested to maintain what? E1. No longer maintaining what? E1. No longer interested to maintain the memory space of E1. Forceful garbage collection. 5. And what is this? E1. Forcefully GC call what? Will it call the destructor or not? That is my question. Quickly. Will it call or not? See, this is my object. E1, E2, E3. X, 1, 2, 3. Some data 10 RS only. Today I am making del E1. Del E1. Will this memory space removed or not? Removed or not? Huh? Remove. Okay. General knowledge is not there. For example, one example I'll tell you. Listen now. Listen. There are 3 friends are there. Who is coming on the international airport side. All of a sudden they found 1 kg of gold. 1 kg of gold they found. In one bag. 1 kg of gold they found. 3 friends are pointing to the same gold. And this person said that I'm going away. Please watch this bag. This person is going away. I'm going someplace. I'll come back. You please wait. Both of them said. Both of them are watching this bag. Is a thief will come and collect away? Thief means what here? Is that thief will come and collect away this gold bag? No. Why? Because they are already pointing. Na? That memory space is pointed by what? 2 objects still pointing to that. Yes or no? And this person also went out. Only 1 person. 2 are there. Na? He also went for some other business. He went for some relax. He went. And only 1 person is there. Either GC will come and collect away. No. And he is saying, they are other went out. Na? I am also going little bit away. And he is also going little bit away. Is the thief will come and collect away or not? That means if no more objects are pointing to this memory space, it is eligible to be collected by what? Now tell me. No longer. How many objects are there? 3 objects. Contains which ID? Same ID. Now del of E1 is the forcibly GC calls. Forcibly GC can't call its destructor because E2 and what? E3 points to what? Same memory space. Did you understand? I'll show you that. One more time. You say, what is next? E2. No longer interested to maintain what? E2. What are you doing? E2 is equal to what are you doing? None. None is also called one same thing. Forcibly GC call its destructor, because who is pointing? Who is pointing? E3. E3 points to what? Object memory space. Are you following? Next, you call again. You call again. No longer interested to maintain which memory space? That time you say del what? E3. That time forcibly GC calls its destructor, because no objects points to what memory space? Object memory space. That time it is eligible to be called by what? Yes. Did you understand? And during this period of time, I called the same object again and again. I will remove this memory space. Now see the clarity. Did you get this clarity, students? So here it cannot call, here it cannot call, here it is calling. Before program execution ended, that means even though multiple objects are participating in deep copy, one memory multiple object, it never call multiple times of number of objects times. It will call what? ID based times it will call. Did you understand? Well, coming to the execution part, you execute it. Okay, destructor example 6.py. 6.py. Now see py destructor example 6.py, one constructor 144. You see E1 object not maintaining. See, no destructor called. No destructor called. Now no destructor. Now it is calling. What is that now? You see what is that is happening. Now available memory space. Finally, what is happening? Program execution ended. Are you able to follow? Why 96 is coming here? Because 2 times it is not calling now. 2 times it is not calling. So this space I should not write. Where I will write, students? Did you understand? I will write to show you that perfectly. What I should do? Here I will write it. Where I will write it? Here I will write it. In this place, when you remove that memory space, I should say what? Tell me. Total memory space is equal to minus of what? What is it? E1. Are you okay, students? In line number what? In line number what? Line number 29. Line number 29. I will write it next line. I will write it next line. When it is becoming this E2, I will write these statements. I am writing here, what is this now? E2. What is this line number? 34. After this is completed, you see, this is done. I'll say total memory space. This is called what? E3. And see this total memory space at this line. You see what the memory space is here? 40. 40. See this carefully. Execute it. See that now. What is it? No longer to maintain what? E1. What is happening? What is that? GC call. What is this? E2. E1 is not defined. What is happening once? Okay. Before that, I need to take it. 1 minute more. I will take it. When it is becoming none, it is not existing. Total memory space. Del of E3, I should not write it. Before that only I need to remove. After that, this E3 is there. Now you execute. Yeah, here also. When I am removing, I should remove that memory space. Yeah. Execute it, students. Now see that. What is the memory space? 144. E1 is not maintaining. Memory space is called what? 96. Because E1 is gone. E2. What is that now? 48. No longer interested to maintain E3. What is happening? Called. What is the memory space now? 0. Wait. Now total memory space is what? 0. First time 144. 96. 48. 40. 0. When program is execution is ended, no more objects are there. That is the another way of accounting this garbage collector. Are you following? Yes. I don't know whether you are following me or not. I hope I'm showing you. What is this concept is called? Deep copy related garbage collection concept. Previous one is called what? Normal object, forceful garbage collection. Previous one is what? Normal object, forceful collection with none. Previous one is called what? Automatic garbage collection with memory space. Right? Who will give you this many examples? It's an important. Shall I go to next? Shall I go to next? Yes. Now I am going to introduce. In this way, first question, sir, how do you know that garbage collector is running? Destructor is calling, I am seeing. How do you know that GC is running? It is a question mark or not? GC is calling what? Destructor, because I am seeing these messages or not? Yes. Now I am questioning, GC is running. You show me one practical point. PVM. ఇంకేమవుతుంగా నేను చెప్తాను ఇప్పుడు. I will tell you that. So PVM లేదు ఏం లేదు ఇంకా. I will come to GC. Students in online, up to here it is clear. I'll come back once again. I'll come back. Students in online, is it clear up to here? Ultimately you tell me, is it necessary to write destructor or not necessary? Necessary or not necessary? Ajit, in first two objects E1 and E2, object could not remove na sir. Then also memory space getting reduced na. See, Ajit doubt is, see, he is asking, you are calling this one. Suppose he is asking line number 28 you are removing sir, but you are destroying, you are removing the memory space here. Ajit, my dear student, remove from 27, you write in where? You write in where? 28 you run. When you remove the E1, how do you get the variable name E1? Yes or no? You did not understand. I understand by looking at your face. Go to Python. L1 is equal to 10 comma RS comma Ajit. Ajit. Right? Ajit. Now I am saying, this is my list. Print of what? L1 comma type of what? L1. You see, import what? Sys. Sys dot what? Get size of. Get size of what? L1. What is that? 88. Okay. Ajit, careful. Now I am saying what? Del of what? E1. What is removed? Okay, sorry, student. L1. Del of what? E1, no. What is that? L1. Removed or not? After that, you are finding the memory space. When L1 is over, how can you get that variable? Your name error is coming or not? Name error is coming. మనకంత లేదు. మళ్ళా S1 is equal to HYD. What is S1? Object. Object. How do you find the memory space of S1? What is the memory space? 52. Okay, now I am removing that object. Remove. Del of S1. Del of S1. Deleted. When S1 is removed, will you measure the memory space of L1? S1. S1. Will you get that value S1? Variable itself is removed, na? Will you get that variable name again? What error will come? Yes. You removed that. You forcibly removed. One person is there, one forcibly over. And next morning, hello, come here. Where is that? What is the error? Name error. You are wrong, he is wrong. Both of them we already done. When you remove the object, do you have that variable name first of all? What is that error called? Name error. When I said this, in the beginning stages of what? Del operator time only I said. Right or not? So, Ajit, are you okay? Now he is satisfied. But you did not satisfy, I know. First of all, that is not a correct doubt. And you are going to that doubt only. So, understand. What is the difference between LEN and size of? LEN will give you number of elements. Who is that asking? Sagar Thakur is asking. LEN will give you what, ma? LEN of, you say, S1. 1 minute. Sagar, S1 will give you number of letters. Number of letters. Understand? Get size of will give you memory space internal, occupied memory space in the RAM. Are you following? Yes. So, that is called what? Size of and then. Sagar, are you okay, Sagar? Sagar, are you okay? Right, got it. Now I am going to move to further. So here I said, if I delete that E1, if I run my code, which error will come, you see? Which error will come? Oh, name error. I will exit from this place. I'll exit from this place and run my code. See that, what is that error is coming? You wait. Now you'll get name error. Error. What is that error? Name error. What is that? E1 is already E1 gone. What is there? E1 పోయింది, E2 ఉంది, E2 కావాలని అడుగుతుంది. E1 is gone. What is the meaning? E2. So that's why technically to understand this memory spaces now, I used, anyhow it is deleting, I will deduct that memory space. Three variables are one memory only, but you are counting the same memory space 3 times. One memory only counting 3 times. 48 plus 48 plus 48. 3 memory spaces counting 3 times. Okay now? Yes. So, he is thinking 3 objects are pointing. Even though we add 3 things, 48 only is expecting. How it will come? E1 memory space, E2 memory space, E3 memory space. E1 memory space similar to E2 also, E3 also. I am summing of it. 3 people are pointing to 1 kg gold. First person weight, second person weight, 3 person weight is not equal to what? Understand at least that? Right. Coming to the point. That is not necessary, my dear student. Now I will go to one more example. What is that example? GC related. Coming to the point back. Actually, to understand this, we have a good practice on coding. Then only you can get this. Come to the point. Now I am coming to GC example1.py. GC example1.py. Print of this is garbage collection class concept, or I will write it directly. A is equal to 10, B is equal to 20, C is equal to A plus B, and D is equal to A minus B, E is equal to A into B. Print of what? Value of A is equal to comma A. Value of B I am writing. Value of B. Print of what I am writing? Sum is equal to comma A. Sorry, what is that? C. And next I am writing here sub is equal to what? Comma B. D. Next I am writing print of what? MUL is equal to what? Comma E. This is my normal code, I wrote it. Okay. So normal code, I wrote it. This is also one program now. This is also one program. GC example1.py. Behind of this program, who is running? Garbage collector. What it will collect? What are A, B, C, D, E? Objects. Which class objects? Int class object. Whose memory space will be destroyed at the end of the program execution. You know that, na? Well, now my point is, how do you know that GC is running inside? How can you impress the interviewer? How can you convince the interviewer? Destructor is calling, okay, acceptable, because we have seen so many examples. How can you convince the interviewer? Garbage collector is running. Sit. There is one module is there. What is the module name? GC. inside the GC module, there is a function called, is enabled. Is enabled. Spell out. Will give you true when it is running. Is enabled will give you true when it is running. There is a function called what? If it is not running, it will give you what? False. Let us go to the previous program and try to use it. Here I am writing print program execution started. Program execution started. The moment when program execution started, garbage collection also will start. Program execution ended. Now I am writing here, I am saying print of is GC running, is GC running, comma, GC dot, what is the function name? Is enabled. Import what? GC. Import GC. Now I will run it. Now I will save. Save this. Careful students. Now saved in the same place. Run this code. PY. What is an answer now? Is GC running? True. That means behind of our program, what is running? Garbage collector. Now there is a GC module is giving one more type of function called what? Disable. What is the function name? Disable. Once you disable it, what will happen? Will it run or not? No, it will stop. Okay. I will go for this. I'll go for my program. I will write it after this operation. GC dot, what is this? Disable. It is what I am running. Is GC running after disable? This is what initially, here I am writing. Initially is GC running, right or not? So initially is GC running. First true. Next one is coming what? Execute it. What is coming? Initially is GC running. After that what? False. And program execution. Now my question is the end of the program execution, is this objects removed by the GC or not? Disable means what? Stop running. Once it is stopped, will it collect? Come on. Will it collect or not? Yes or no? No. Everybody will feel that no. But it is yes. Who is that yes? Yes. How? Don't laugh, ma. He said a unique answer. Manol atle chestha untaru. So when he says you appreciate it. Appreciate. He said yes, now you listen his answer. If you laugh like that, what is the use? I have to tell you one goods rail story. I have to tell you. Okay, at the end of the class, after my topic, I will tell you that. Okay, let me continue. GC stopped or not? Once it stops, will it collect the garbage collector or not? Is it one of the important point or not? Can I explain that? Okay, go to that. Again, I will do what? In middle of it, I will say what? GC dot, what is the function name? Enable. After this, I will write it. I will write it here. What is that? Here. Is GC running after what? Enable. What is the answer is coming? First time true, false, again true, like that. Disabling, enabling, disabling, enabling. When I disable it, is GC running or not? Answer my, whatever you feel, you tell me. Once you disable it, definitely it will not run. What student will think? But it will run. What is the proof, sir? It is a compulsory question when you go to higher level interviews. Shall I show you the proof? Even though we disable it, garbage collector will call its own destructor for eliminating its object, because in 3.10, 3.9 onwards, it is not under the control of what? GC module is not under the control of the programmer. Because of OS, even though you disable it, the OS and your underlying OS and your PVM will, when you disable it, immediately it will enable it internally. And for you, the message is showing according to your disabling and enabling only. Let me show you the proof. Online students, did you understand this point? Now I am going to say the another practical point. Go to this example number 3, example number 2, or example number destructor. Are you following me? Are you following this point? This example only I will take. This example I will bring it. Go to this place. Take it. I am going to take it. Now you are having big doubt. Once it is disabled, how it runs, you are having the doubt. I'll show you that. Nothing to worry. GC example 2 dot what? Py. What is this now? Beginning, tell me. Program execution ended. I will carry my message. Is GC running? Come on. Come on. First one is what? True. After that, immediately what I am doing? GC dot what? Disable. 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 That means what? I will take it. This answer once again I will print. Is GC running after? Is GC running after? What is that? Disable. Definitely it is going to print what? False. False means everybody will think that it is stopped. Now, once it is stopped, what objects you are created? 2 objects created. Program execution is ended. What are you doing? Sleeping. After that sleep, actually according to the property of disable, it should not call what? Destructor. Yes or no? Yes or no? Yes. But what will happen? Because of your disable, PVM and underlying OS is not going to make you to disable this destructor internally. It will enable it immediately. Because in your real-time projects, by mistake, if you call disable in one of the project, it is going to full of memory space is occupied by your objects. Memory hanging problems will come. To avoid that memory hanging problems, OS will not allow you to disable. That's why in present versions, there is no meaning of GC module. There is no power is given for GC.disable. Are you following me? Let me execute this code. Even though you disable it, your destructor calls 2 times after the program execution is done. Save this. Come to the point. Execute. PYGC. See that? GC module not imported. Okay. Execute. See that? 2 objects. Execution ended. And true and false. Destructor calls now. On the board. Called. What did you understand? Do you have any power of disable? That indicates GC is not under the control of us. GC under the control of what? OS and PVM. Even though you disable it, it is automatically calling. Understand? This entire class you listened. Will you write destructor in our real time? No. But beginning, if I say this is not necessary, if I say, you will look at me differently or not? Now, if I say, you will satisfy. Yes, sir, you said correct. But this knowledge is important or not? Will the normal student will have this knowledge? No. So, let me open the destructor. Let me open the destructor. Now, I'll go to that. I'll go to my place of this oops, of this destructor, any one of the nodes you will take, and I will take it. Destructor nodes I will bring it. Go to this 6 p.m. Under this whoops, under this destructor, under nodes I will create. Nodes I will take it. Under the nodes, I'll paste it. Open it. You only will read. Everything you will understand. Start. We know that garbage collector is one of the inbuilt program in Python, which is running behind of every Python program, whose role is to collect unused memory space and improves the performance of Python-based application. Every garbage collector program is internally calling its own destructor function. The destructor function name in Python is def __del _self. Right. By default, destructor always called by garbage collector when the program execution completed for deallocating the memory space of objects which are used in the program. Correct? Whereas constructor called by PVM implicitly when object is created for initializing the object. Anybody ask you the difference between constructor and destructor? You will say this. Actually, there is no difference at all. Difference on the? No. But they will ask you constructor, destructor. That rhythm is there, na? That's why interviewer will worry about that rhythm. Destructor job is what? Eliminating memory space. Constructor job is where putting the values. Any difference? Huh? No difference. Length and size of, there is a difference. Correct or not? Come on. When the program execution completed, GC calls its own destructor to deallocate the memory space of object present in program, and it is called automatic garbage collection. Hence, we have three programming conditions for calling GC to make a garbage collector to call destructor function. First one, by default or automatically GC calls destructor when program execution completed. Did you understand? Next, make the object reference as none for calling forceful garbage collection. OBJ name is equal to none. Next, delete the object by using del operator for calling forceful garbage collection. Del object name. Syntax. Def __del __ of self. Right. No need to write a destructor in a class of Python because GC contains its own destructor. Are you okay? Come to garbage collector. Garbage collector contains a predefined module called GC. Here GC contains the following functions: is enabled, enable, disable. GC is not under the control of programmer, but it always maintained and managed by OS and PVM. Note, Python programmer need not to write a destructor method or destructor function and need not to deal with garbage collection process by using GC module because PVM and OS takes care about automatic garbage collection process. But this knowledge is important. Understand or not? Yes. So, even though we don't write in coding destructor, but a compulsory interview will ask. So on this, how many questions I can raise? 50 questions.